Hello everyone, I am Showardo Pal, and today we are going to do the analysis of result analysis and report generation of microstrip patch antenna using HFSS. So these are the parameters that we will be discussing today. And in the previous video, I have shown you how to design the microstrip patch antenna by the proper method, step-by-step method. And in this video I'm going to discuss about how to do the result analysis and generate the report. So for that I have already created a PDF and I will show you step by step how to create that PDF. Let's jump to the HFSS first. So this was the model that I created in the last video, and one thing that I did off screen is that I have analyzed the blank model, and before doing anything with the result section, as you can see the result is blank now. And the one thing that I changed that was not mentioned in the last video is the frequency section. So I have changed the frequency to 9.5 gigahertz and the passes to 15, and I have also changed the sweep frequency from 7 to 15 gigahertz. Okay, so you should be changing them accordingly and do the analysis after that. So let's start with the generation of the report. So as you can see, uh, here the first thing that we need to do is antenna configuration and dimension. Okay, so for that I will be going to HFSS, the design properties. So these are the variables and the properties that we have used in the model, and there is the dimensions that we have used respectively. You can view all the variables from here and change the variables if needed accordingly. So you can take screenshot of this thing and attach it to your report in PDF format, which we will be creating. Here is my PDF, and this is the dimension, and here the variable names are different, but the more or less the whole thing is same basically. So after that uh, we will be uh, creating yes, so for that, after that we will be creating the S11 parameter, the reflection coefficient. One thing before that is yes, so HFSS design properties, and this is the design variables. Yes, so after that we will be creating uh, the reflection coefficient graph. So this is how it will be looking, and for that I'm going to show you how you can do that. Just go to HFSS, go to results, go to model solution data report, rectangular plot. Then I'm going to plot the S11 parameter in dB scale, as you can see, and just plot it. Okay. After successful the calculation and solution, you will see the graph similar to like this one, the similar to the one shown in this graph also, and we will be adding marker to this. So one will be adding at the lowest draw of the graph, and one at the minus 10. So these are the three markers that we have added, and this will be used in the later part of the video for calculations. So let's see what are the next step. So the next is resonance frequency we have to calculate. So for the resonance frequency, what we need to do is, one second. Yes, for the resonance frequency, as you can see from the graph, there is a draw in this M3 marker, and respected to this you have a marker. We have a point of 10.14 gigahertz frequency. So this is the frequency at which the reflection coefficient is at its minimum point, and this is the frequency at which the antenna resonates. Okay, so after that we will be calculating the up to upper and lower cutoff frequencies. Okay, so for that, as you can see from the graph, there are other two markers. The M1 represents the lower cutoff frequency and the M2 represents the upper cutoff frequency, and you can respectively calculate the values from the marker positions. The same is also present in this graph also. You can mark your markers accordingly in your graph. So after that, we have found the frequencies to be of 10.31 as upper frequency and lower frequency is 9.94, and using those frequencies you can also calculate the bandwidth. The bandwidth is suppose here is 0.37 gigahertz, and after bandwidth, yes, as we have calculated the bandwidth, the sixth part is the variation of real and imaginary part of the input port impedance over the frequency. So for that, what we're going to do is head over to this. This is how the graph will look if we plot this. So we are going to plot this thing accordingly. Go where we come into HFSS, then go to create model solution data report, rectangular plot, z parameter z11 in dB scale. No, sir, imaginary and real scale. So real scale, I'm going to do this first. New report. One second. Is the real part of this, and this is the and after that we will be plotting the imaginary section, which is add a trace. So after adding the trace, as you can see, both the graphs have been plotted, and you can see both the graphs have been plotted simultaneously, and there is the marker of the which shows which color represents what. So after that, as you can see, this graph is very much similar to the one shown over in the PDF, and yours graph will also be the similar, and you can take the screenshot of it or copy the image and paste it in your reports accordingly. So after that, we have completed till now. So the next part is variation of the radiation pattern 2D, 3D and polar form. Okay, so for that, what we're going to do is come over to this section. I'm going to first show you the 3D plotting technique. So for that, what we need to do is, the one thing that we need to do is set up a far field region for this. For viewing the 3D gain, we need to set up a far field region. So for that, we'll go into HFSS radiation, insert far field setup, infinite sphere, and this should be 0 to 60, and this should be from minus 180 to plus 180, and step size may be 10. Okay, it's no problem accordingly. So after that, you can see we can go to the result section. There is create far field report and 3D polar plot. So we are going to plot the frequency at our desired frequency. So gain and total gain in dB, of course, and the y-axis should be I think, yes, no problem. I think we now come to the okay. So for the frequency section, we are going to change it to the frequency at which the antenna is resonating. We have calculated that antenna is resonating at 10.14, I think 10.14 gigahertz. So 10.14 gigahertz is supposed to be set over here. This is 10.14. We close this. Yes, after this we are going to click on new report. So after the successful generation, as you can see, a 3D form has been plotted, and it might look something different from the one shown over in the PDF, but the thing is they are actually the same. You might be seeing it from different angle. As you can see, the whole thing is actually same. One thing is that you can the antenna alignment and the orientation may be different, the one used in the PDF, and the shape is actually the same if you see this thing from the correct position, of course. And the shape is something like that, and you can see this thing is very much similar to the one shown in the PDF. Okay, so for the next plot that is shown is at the different frequency. We can also get this for 3D plot also, but we need to vary the frequency this time. For that I am going to do this. Go to the results, create far field report, run 3D polar plot, gain again total dB, the frequency should be sweep. Let me check. Yes, gain total dB. I should be around 11 gigahertz this time. So I'm going to set this 11 gigahertz this time. Okay, 11 gig have been set. Now I'm going to create the new report. Yes, as you can see, the report have been generated. It is also very much similar. You might feel it different on the angle you are seeing it from. So if we are viewing the thing from this angle, we will be able to feel the similarity. The whole thing is basically the same, maybe at a different for alignment the antenna has been taken at that time. So after that we can come to the next part. This is the third one. You can also plot this thing also, very similar to the two shown over here in the earlier cases. Go to the create far field and 3D polar plot, then gain total dB, and this should be 5 strip, and this time the frequency should be 15 gigahertz, so the result would match. So this is the 15, and after that let's wait for some time. Okay, so this is 15 gigahertz. So going to click on new report. So yes, the graph have been created, as you can see. Let me do one thing, that is yes, this is graph is very much similar to the one shown over here. As you can see, the orientation needs to be checked. So we have completed till now. Now we need to see what's pending. So after that we can see that we need to plot the rectangular and the polar form. We need the yes, rectangular portions. For the rectangular graphs, Yes, we can plot that also. You gain total and 5090. Go to the result section, create far field rectangular, gain total. In total, we vary the phi. The gain needs to be of dB. Yes. Gain needs to be of 3 dB. The phi needs to be of theta 90 degree. Yes, as you can see, graph have been created. This is the one very much similar to this one shown in the report. The results might vary a little bit depending on various other conditions also responsible. So this is the graph in the rectangular form, and the other one shown in the previously was 3D polar form, and this is 2D rectangular form. And after that we can also plot this in this pattern, the radiation pattern. We can also plot, I think. So for that we will go to result, far field, radiation pattern. The other things should be same very much. Okay, the gain, one thing we need to do is change it to swift. Gain total dB. Yes, so 5. I'm going to change it to okay. Let's wait. 0 and 90. Okay, close the thing. So we need to change the frequency now, and we need to set it to 10.14 as we have found the resonating frequency to be. 10.14. It's at 10.13. So we need to change that to 10.14. Oh, the result will be very much close. We don't need to bother about that very much, but still. Okay, just new report. Now you can see the report have been created, and this is the form in the radiation pattern form, which is the very the pattern is in the radiation pattern form. And then we can plot these values also. Let me check this thing once. Okay, so we need to plot that also now. So this is the plot of gain phi and gain theta at 0 and 90, 0 and 95. I can also plot this very much similar to the one shown over here by going to results, far field report, rectangular plot. So gain, check what is the frequency they use. They use the custom frequency, which is SIP. The gain Plot the phi first, gain phi. I want to deal the dB, yes, dB. So gain phi dB at what frequency? So the phi should be 0 and 90. Zero and 90 should be selected. Yes, and the frequency should be 10.14. 10.14. And what is this thing? We will click cancel. So we are going to click new report, and the frequency up to this have been created. So we now need to go to gain theta and dB also. Other things will be the same, and trace. So after that you can see the value, the graph have been created, and this one is very much similar to what is expected. Okay, so after that we are going to visualize the current and electric field distribution. Okay, so for that we are going to do is, this part have been completed. We are going to move to the results, the model. Yes, so now in the model what we need to do is, we need to go to the solid. The copper patch needs to be selected for visualizing the electric and magnetic field. I'm going to show you the electric field. You can try the magnetic field as well. Plot fields, electric, magnetic of electric. The frequency should be, I guess, 10.14. 10.14. Magnitude of this should be the same. Done. Let's wait. So as you can see, the graph has been created. One thing that we need to do is change the values a little bit so that you can visualize the thing better. So the one used is green, so 9 1 2 3, maybe this will apply. Okay, we'll reduce that a bit. 7 1 2 3. So you can see this is the electric field distribution, and one thing that we can do is to show that the field is moving. We can actually animate the thing over the phase 360. So 0 to degree. Okay, So after creation, as you can see, the electric fields are moving in this way. You will not be able to visualize it properly in this manner, but you can somehow get the idea a little bit. So after that, what I'm going to show, this is the magnetic field distribution over the patch. You can also similarly do for magnetic field accordingly. Then one thing I'm going to show you is this electric field distribution. So actually we have in the last case we have actually plotted the electric field over the patch, and we can also plot just surface current and other parameters over here. And now I'm going to show you the electric field over the this plane, the sheet. So we don't have the sheet in this model right now. We can add that very easily also. So we need to have a sheet. This is not will not work. We need a sheet, actual sheet. Yes. Okay, the sheet is not actually proper in proper place. We need to have it adjusted to that. So the position should be 0. The y position should be with ground y2. Okay, let me do that first. Okay, this thing is like that. We need to do is add the thing accordingly. The axis need to be along y, I guess. Okay, no, y will not work. The x dimension. Okay, so this should be axis should be x, and this should be the height of like width, length of ground. Maybe I'm not sure. I'm going to try this if it's work. Yes, it's coming to shape. So we need to list z. The z should be okay. The z should be actually minus coax height, coax height. So this thing, I think now we are actually got some problem. Need to fix that. So this is the rectangular created, as you can see. So we need to have it changed. Okay, so the thing should be the let me check from the properties. Okay, so this should be the height of the red box, height red box. And this z should be minus coax height. Yes, this should work right now. Oh yes, this as you can see, this is working. We need to do is XYZ. Okay, let me do one thing then. This thing is this one. Okay, so y-axis is not properly aligned, I think. So we need to align that y. Y should be 0. As you can see, the sheet is in perfect middle of the structure, and we can now work upon this. So what we need to do is plot the electric field magnitude over the surface. So for that, what we're going to do is click on this plot fields, electric and magnitude of electric. I'm going to use the frequency of sweep and frequency of 11.14, so 10.14. So this is the plot of the magnetic field over the sheet. And what we can do is, right now you can actually animate the thing so that you can visualize the how the wave actually propagates. So yes, this is how the wave is actually propagating, as you can see. And you can take the screenshot of this thing and attach it to your report accordingly. And this is what we need to do. Let me check this once again. So yes, I need to show the characteristic port impedance. So much part of this have been completed. So for that, for viewing the characteristic impedance, what you need to do is result solution data, and just click on Z0. You will see the characteristic impedance. This is the characteristic impedance, the resistance and the reactance part. And for the next part, then you need to do is plotting the electric and magnetic field in the similar way as I have showed. As you can see, this I have already shown you how to plot that, and this is only up to that. And all our tasks have been completed, and I hope that you have enjoyed the video. Thank you.